Let's talk about the Fick equation. You know, a good question to ask is, why do we measure heart rate during exercise? And the answer to that question can be explained by using the Fick equation, also known as the Fick principle. The Fick equation is listed here. VO2 with a dot over it, so that's rate of oxygen consumption, equals QC times AVO2 difference. All right, let's go through each of the parameters here. VO2, I missed my dot there. VO2 is rate of oxygen consumption. So that would be units of mLs per kg per minute, or maybe liters per minute. QC is cardiac output. And it's calculated as the product of heart rate, how fast the heart is beating and beats per minute, times stroke volume, the amount of blood extracted or ejected with each beat, and specifically the amount of blood ejected from the left ventricle of the heart. AVO2 is the difference in oxygen in the arterial and the venous blood. So you measure the oxygen leaving the heart in the blood, and you measure the oxygen levels in the venous blood returning. The difference between that amount of oxygen in the arterial and the venous would be the amount that is extracted from tissues. When we're dealing with exercise, the tissues really end up being muscle. Of course, there's other tissues, but muscle would be the predominant tissue extracting oxygen from the blood. And that oxygen is then used by the muscle to convert chemical energy to mechanical energy using the aerobic energy pathway. So the venous blood returning after going through a muscle would have less oxygen content than the arterial blood level of oxygen. So I'm just going to rewrite this equation as VO2, rate of oxygen consumption, is equal to the product of heart rate and stroke volume times AVO2 difference. That's how we would say that. This becomes a really nice way to explain why we measure heart rate during exercise. During exercise, stroke volume and AVO2 difference change fairly predictably. During steady state exercise, they typically plateau. That's not always the case, but typically. And when they plateau, they end up being constants in essence. Therefore, heart rate would be directly related to rate of oxygen consumption. Now, to measure VO2 in the lab, we have to have a sophisticated piece of equipment where we have a mask hooked up to the person. That mask is connected to a computer where we're collecting all the expired air from the person, and we're measuring the amount of oxygen content in the expired air, as well as CO2. And from that, we can figure out how much oxygen was used by the tissue. So it's a pretty complicated process, and it's not something that's easy to adapt to using outside in actual exercise. Heart rate's super easy to measure because we just put on a heart rate monitor and we're able to pick up the rate of the heart beating. So let's look at some data here. I've shown you, so this is the way that, this is the form of the equation that I'll use to explain why we measure heart rate during exercise. Here's some data from a cycle graded exercise test. The light blue line represents the amount of resistance of the bike, okay, steadily increasing. So that's the graded exercise part. The red represents rate of oxygen consumption until the person stops exercising here and stops pedaling. And then the darker blue line represents heart rate. And you see VO2 increases with intensity, which is expected, and heart rate also increases with intensity. Because heart rate and VO2 increase during this test, I'm going to redo this plot, and I'm going to plot VO2 versus heart rate. And that's what these data look like. So here's heart rate on the y-axis, VO2 on the x-axis, rate of oxygen consumption, and these are the same data points as in the previous plot, just heart rate versus VO2. That looks really like a straight line. In fact, that correlation is 0.9729, and this is for one subject, the same subject of the previous data set. That means that if heart rate changes, VO2 changes. If heart rate increases by a certain amount, VO2 is going to change by a certain amount. What we really want to know when we're exercising is how much oxygen the muscles are using, and therefore how active the aerobic metabolism pathway is. We have a hard time measuring this during real-time exercise, but it's super easy to measure heart rate. Because there's this strong linear relationship between heart rate and VO2, we can measure heart rate to predict VO2, rate of oxygen consumption. That's why we measure heart rate during exercise. That relationship holds up as long as stroke volume and AVO2 difference change in a predictable manner. If these change unpredictably, then this relationship between heart rate and VO2 is disrupted. For example, if you become dehydrated, if you have a reduced blood volume, your stroke volume could change in an unpredictable manner during exercise, and that disrupts this relationship between heart rate and VO2. But in general, we're able to have an understanding of rate of oxygen consumption by measuring heart rate. We don't really care what the heart rate is. What we care is how heart rate changes relative to VO2. And that's why the Fick equation is very important. So you should understand the Fick equation, the different parameters in that, and understand this relationship between rate of oxygen consumption and heart rate. Okay, thank you.